Okay, so we're gonna demonstrate how to calculate the volume of a sphere by solids of revolution. So we know that the volume of a sphere is this. So we're gonna try by the solids to demonstrate that this is true. So first of all, we're gonna do here a half circle with a radius, and we also know that this is in the negative axis, a negative radius. So we know that to calculate radius of a circle, we can use this formula. So we only have to subtract for y, and we're gonna obtain the following. So with this, we got this part, but we are gonna do it as a full circle. So we can now integrate this. We know that the limits are the minus radius and the positive radius. So it will be like this, pi, and the limits established that are r and minus r. And we're gonna use this y equals this, right? It's gonna be square root of r squared minus x squared, this to the second power times dx. All right, so now the square root cancels with the power, so we only got r and r squared minus x squared dx. So in order to integrate this more easy, we're gonna separate each one of them as following. It's gonna be pi r minus r squared minus pi r minus r x squared. So now we can integrate each one of them, and we are supposed to obtain this result. So we know r, it's a number, so we can take it out and we only get it as alright, because it can be any number, so in terms of x, we don't need to keep it inside. So now we integrate this. So the integral, it's gonna be x, and here it's gonna be x to the third over third. So now we substitute all the r in x, and we get the following. It would be 2r, right? Because when we substitute it, we get r minus, and because this is negative and the sign is negative, well, we get positive, so it's 2r. That's why we get that. And for the other one, it would be pi times r to the third, and because of the sign, we also get r third like that. So now we multiply this one, that will be like just like this. Alright, so finally we get, I'm gonna put it over here, 2 pi r cubed times 2r So now we only have to subtract, and it will be like this. So this is equals 4 pi and 3. So we now can compare to the formula of a sphere with the result we got, and we can see it's the same, right?
To find the volume of a cone through a revolution solid, first we have to draw a line with origin at 0, like this. We know that line, the x-axis has a length of h, and the y-axis it has a length of r. Now we will rotate this line about the x-axis like this in order to make the revolution solid. So the reflection of the line on the x-axis will look like this, and once it's rotated, the solid will look like this. Right, now we know that the equation of a line is y equals to mx plus b, where m is the slope and b is the y-intercept. Here, as the y-intercept is equal to 0, we can just get rid of the b. So we have the equation y equals to m times x. Now, the slope of a function is given by the rise over the run. So its rises are units, and its runs throughout the x-axis h units. So this is our m, and we multiply it times x. That's the equation of the line. Now, we have to draw a disk that goes through about half of the figure, like this. This disk has a radius of the equation of the line. So radius is equals to r over h times x. Radius. Then it has a width of dx. Right, so we know that the volume of the cylinder is equal to pi times the radius squared, which is r over h times x squared, times the height, which is dx. Now, in order to find the complete volume of the cone, we have to integrate this from 0 to h, which is the total length. So it is the integral from 0 to h of pi times r over h times x squared times dx. Now to integrate this, we have to solve the square. So it will be the integral from 0 to h of pi times r squared x squared over h squared times dx. So as we are integrating with respect to x, then all the variables that are not x can be treated as constants. Therefore, they can exit the integral to the left. So then we have pi times r squared over h squared times the integral of ax squared with respect of x. That is a direct integral, so we got, let's go down here, we got that pi times r squared over h squared times the integral of x squared, which is x to the third power over 3, plus a constant. Now, the constant is the actual volume of the figure, so we have to get the constant. We do that by substituting the limits of the integral into the integrated equation. So 0 and h. So the equation for x equal to h would be pi times r squared times, substituting h instead of the x, would be h to the third power over h squared times 3. We can cancel out the h's like this, we get just one h on top, and that is equal to pi times radius squared times h over 3. Now, if we substitute the 0 here, we get pi times radius squared times 0 to the third power over 3 times h squared, which is equal to 0. Then we subtract these values, so as the second one is 0, the result is the upper value, which is pi times r squared times the height divided by 3, and that is the volume.